So this is really special to me. I think I've been working with Luke and Rajan for a little bit, just sort of like, sitting in the same office, learning more about the problems we're working on. And in particular, I think a lot of the RAG or a lot of the retrieval that most people work on really is around just PDFs and text, which is also very important. But um, some of the stuff that Rajan's going to share is pretty exciting. It's around things like movement, detecting faces, a lot of structure, and in particular, a lot of structure over very multimodal data. Very few companies have really thought about this. I think Cohere is the only one that has trained like Cohere and Voyager has trained a good image model, but there's really not much to be said around, multimodal structure and all of that. So yeah, Rajan, take it away.
Yeah, absolutely. So let's get into a bit of background to begin with. So my name is Rajan. For the past 4 months, I was a research engineering intern at a startup called Kino AI. Before that, I spent about 2 to 3 years doing multimodal research, independent machine learning research. And this fall, I'll be joining Amazon's AGI lab to be working on reinforcement learning for multimodal agents. And Luke, if he's not frozen, you might want to give that a bit of background. Otherwise, I can just go a little bit for context. Luke is the CEO of Kino AI, and he's been working on this for maybe the past 2-ish years. So today is going to be mostly about retrieval. It's very important to think about multimodal data, specifically, how do you deal with video? Video is a bunch of moving frames. Those frames are connected to one another. There is audio that's happening. They're saying text. There is emotion behind this audio. And this all happens for countless frames. And so if you want to do RAG and you want to do effective search, you have to do really good retrieval on finding any piece or any moment of what happens in any of these frames in that video. That is a lot of context, but we can't just treat this like a million tokens of text. We just treat it as unique video that can be searched in multiple different ways. So this is Kino. Kino is a video search and agentic video editing platform for filmmakers. Video editors have the ability to index all their footage and search across it nearly immediately. It is all transcripted. There are highlights. There are people found, and it is all AI indexed nearly immediately. The idea of Kino is that you, as a filmmaker, can become infinitely faster. You can find any piece of footage you want. You can make blurs. You can make draft edits. And this becomes incredibly useful when you're dealing with quite literally hundreds of hours of footage. And you need to find that 1 5-second moment that matters the most to you for your plot or for your video. This would be one of the best possible examples of needing video search. This is quite literally when there are those needles in the haystacks, and there are those customers who quite literally have to go through 7 to 8 hours of footage just to find that 5-second clip that is an all or nothing for the quality of their final output. Whether you're making TikToks or movies or TV shows, every piece and every second matters, especially as attention has become so important, so valuable. And so when I started my internship at Keynote for the past 4 months, a big part was how do you find these exact moments? How do you find these needles in these multimodal haystacks? I think the best way to communicate this fact is by talking about video. Video is inherently what I called earlier 4-dimensional data. There are so many different ways in which RAG can just fail if you focus on one or the other. You can hallucinate visual details. Sure, we've improved our image embeddings a lot. But what happens when something happens in time frame 1 happens in time frame 4? How do you get these two linked together? When you have 2 different characters, how do you fuse it? How do you link them? When you have some action that is being done, how do you know if someone's picking something up or whether someone's dropping something down? Those are 2 inherently and entirely different situations that have 2 different meanings. I like a lot of analogies to the idea of text. If you have the phrase, I am happy and I am not happy, even though there's 3 similar words right there, all 3 of them in very similar positions to one another, they are completely different in meaning and therefore should be treated completely differently. The same applies here. And so I kind of broke it down to like kind of three core things that you need when understanding some video. To know what was said by someone, what was done by someone, or multiple people, and what has happened and how the thing that happened in the past is going to influence what's going to happen in the next couple frames. That's kind of how I've narrowed this thing down. And there's a lot of, I guess, core problems that people spent years researching in the context of text and now image that now are happening with video. We are dealing with not just pixels that are 1,000 by 1,000 pixels that makes an image. We're now dealing with hundreds of those frames. And so there is so much visual and textual content that we have to somehow tokenize and embed. We have to deal with countless different people speaking to each other, people with different tones, people with different emotions, different backgrounds. What happens when there's text on screen? How does that influence if something says Canada versus US in the background? That can mean completely different things in the context of a completely different video. If two things happen really fast back to back and we're embedding both of those things as one long video, how do you differentiate between the two? Scale problems that happen with scale happen a lot more obviously with video because there is just so much more data to deal with. And once again, video is not just long text. Yeah, sure, we're having the context window scaling problems. We can double our context window every year, for example. That's not going to be enough when you're dealing with this type of data. You can't just throw it all and concatenate it all. When you're dealing with multimodal signals, how do you know what was like said versus what was shown versus like what was a moment? And I'll get back into that part really in depth later on. And then when you have so much data, I mean, how do you make this feel instant? How do you make it feel as instant as a semantic search with text and RAG? We spent a long time understanding how to optimize RAG for text and even sometimes for images and visual RAG. This is a completely different problem. And so I kind of want to show you a bit into like what Keynote does and then break down kind of how we approach these problems. So for example, in Keynote, you can just look up massive crowds. For example, this is an event called the Socratica Symposium. I believe we had about 50 hours of footage from this event, potentially more. And if you look at massive crowds, you want to see visually stunning clips of when there are a lot of different crowds, when there's a large crowd, and when this is kind of happening. And so we're showing the top 30 results of large crowds. We're showing 10 highlights here of when massive crowds were happening at certain moment times and how that was like a meaningful moment. We also have titles here. This is a summarization of everything that's happened, as well as a lot of different metadata that we also store. If you want to search for an individual person, you can find out, for example, this is Brian, and he spent a long time on film trying to find the Ethernet cable across like 2 or 3 different videos. How do you identify that this is the person who is doing this kind of, who is on the kind of quest to find the Ethernet cable? How do you even index that and then search for the exact moment where he's either holding, mentioning Ethernet cables or something adjacent to that? That's an inherently pretty hard problem to find exactly when this is happening. Within Keynote, you can index footage in a lot of different ways. We do highlight indexing. So for example, this is a video montage playing, showing various people working on different projects, interspersed with text about artists, engineers, founders, and researchers. That is inherently what's happening on the video. And we can index this highlight as it goes on. You can find out what the general purpose of a 7-minute video is. So in case of right here, it's finding the Ethernet cable. We have long descriptions of, I guess, what's happening, where the driver stops the car to record cows in the field and the driver yells at the cows. As well as like you can get core highlights that go like into, this is Chris, and we know that Chris laughs and puts his hand on his head. How do you identify that this is Chris, know that this is Chris, and identify that the actions that he's doing in this one segment from 20 seconds to 24 seconds? These are a lot of like the different sub problems that we've taken on at Keynote that all contribute to this massive video search and agentic video editing problem that we've really approached and tried to solve. So I guess I'm gonna like to bring it all together. Here are some of the core problems that I've been mentioning. If you cannot find a key moment, if someone wants to find when the demo was revealed, speech recognition is not perfect. There are words that are inherent to us that may not be universal. Embeddings are often reliable, but often also require like more ranking to fill in those gaps or to improve precision over recall. There are a lot of false positives that can happen. If the video is blurry, if you aren't entirely sure what's happening, if there's not a lot of training data in terms of like labeled training data for video, we can get a lot of problems. If transcripts are not always the most accurate, and someone wants to search for a very specific moment, if that transcript's not accurate, that search is just not showing up. Scale, searches can take a long time, especially because, once again, we're dealing with hundreds of frames, not necessarily just one frame that's an image. And also, like, let's say someone wants to upload an hour-long video. We've dealt with it a long time. Hour or 2-long videos. You can't just throw the entire thing into a VLM. You can't just embed the entire hour-long video. You lose so much context. So how do you then regain that context later on? How do you know who she is if she is mentioned in your video? How do you know who this face is if this person was first introduced maybe 45 minutes previously in the video? And so that's what we have to kind of consider things as a multimodal situation, not just like a singular modality of different types. And we're not comparing one modality to another. We're thinking of this modality as 4 branched out modalities. We maintain these temporal features. We can't just take a bunch of image embeddings every second across 10 seconds, mean those out. That does not work. I'll give you a pretty cool example of that later on of how that's a core problem. We want to preserve linearity. We want to know what was done. If I'm picking up these sunglasses versus putting them down, that's a completely different problem. If my intonation is more confident versus intonation is more sad, that changes the entirety of when I want to look up videos of people being sad. If they're visually not showing it, their intonation shows it. Facial expressions, actions, we don't have really strong multimodal embeddings. There are a lot of them out there. There's some closed source, some open source, some publicly available from large cloud providers that are pretty good at multimodal embeddings, but we cannot rely on them for sure. And this is kind of like going into scaling laws. We have to wait more time for these to improve. But at Keynote, we didn't want to wait for those to improve. And there's a lot of ways to take what we already have and get really, really, really high quality video search at it. And so this is where I introduced the idea of a tree. A lot of what was done is thinking about everything we do in our day as one long video, and then breaking down this video into decomposing this day into like a bunch of sub events. My day is broken down to morning, afternoon, and evening, and in each of those are sub events. In each of these, there's more sub events, and it goes on and on and on and on. Until we get to the most granular thing where every single word I say or every 5 seconds of what I say right now is a different event. By doing this idea of clustering and by doing this idea of grouping things, we maintain linearity. We also maintain different types of depths. We maintain the granularity of when I say the word rag versus when I am doing this talk as a whole. Those are 2 completely different time lengths, requires 2 completely different indexing. I don't really want to index an hour-long video and also a 5-second video. But I do want to maintain like the general context of what's happening at different types of different lengths and different variable lengths. And so this example of a tree is what guided us throughout our entire approach into how do you search across any moment that someone may need. And the answer is you have to index in multiple different ways. Treat text, treat visual cues, and treat moments as 3 distinct things. When you want to examine text, what people say is incredibly important to the context. So extract what they say, use a very good model, use Whisper v3, use GPT-4, just grab, use whatever you want, and store from any start time to any end time what they've done. For any visual cues, use multimodal embeddings that do not have audio at all accounted for, just visual cues, and treat those visual cues in the best way possible. Treat it like 3 different subproblems, where this subproblem is now, okay, how do you examine this footage? If there's a bluebird coming across, that's going to be hit by this visual cue, by this visual index. And then there's going to be curated highlights. Highlights are going to be summaries of what happens across your video. It's going to be a VLM answering pretty much whatever is happening in any key moment. And we want to use this as a text-based representation of relatively complex videos that are still multimodal. And the reason that we need that is when you want to answer a question about a video, the best way to do it right now is to ask a VLM. So it's important that we try both asking that VLM as well as also getting these core multimodal embedding models to both do the trick and then aggregate those results. In the context of our tree, we want to treat these visual cues and these transcript cues as leaf node. These are the most granular you're ever going to get. This is going to be summaries this is going to be what someone says between 5 seconds and 10 seconds, as well as what embedding represents what happened between 5 seconds and 20 seconds. Then treat these highlights, treat these core moments that are VLM indexed as parent nodes. Then treat those parent nodes as one large root node that is going to be your description of what happens in your video and which video represents what thing. Then it comes up to the user to define how much depth they want and what they're looking for. So going to text indexing. So the first type of indexing is when you want to just take your piece of text and find when someone said something. This is the most useful when myself, for example, as a filmmaker knows what was said. I just have no clue in these thousands of video files where this exact moment is. So for example, if I want to search up the word, when I said the word compute, I know that in this video at 34 seconds, I use the word compute. This is going to be, this uses really, really fast text-based search, looking for keywords, and there's also the option to embed these transcripts. Whether you choose to embed these or not is a decision that depends on how well your user knows their footage. If they are very, very familiar, it is very likely that they'll know what phrases were said, what words were said. And then there's the cases where you're dealing with an inherent black box. This is just a large store of footage. You have no clue what's happening in it. I want to find when someone mentions something related to compute. I have no clue whether they mentioned the word compute. That is a job for these dense embeddings. This is a highly dependent problem. And this goes into the whole idea of know your users and know the type of footage you're dealing with before making these core decisions. Because this is a make or break in terms of latency, as well as pre-processing time, and may not always be the most necessary. Visual indexing and highlight indexing are a little more complicated. For visual indexing, there is the whole idea of using image embeddings. So for context, this is a picture of me about a year and a half ago, maybe 2 years ago. I built a little wearable. You just put on your hat as a webcam, records everything you're doing, and you can search for any moment that happens in the past 7 days. This is when the idea of like a video embedding was like, it didn't necessarily exist, or maybe I just didn't know about it. And so we chose to every 10 seconds take the image of what's happening, as well as the transcripts within those 10 seconds, and throw all that context into a language model to answer any question. So if I want to look up anything about today's lecture, I'll just prompt decomposition, look up today, find all videos related to today, look up things that are related to lectures on Hinge Forces, share those top results, throw that all at a language model, answer that question. And this is the most naive way to go about it because there's no temporal thing happening at all. We're just dealing with visual cues. And sure, this works, but we've grown a lot since then. And so we want to use multimodal embeddings. As of right now, there are not many good quality multimodal embeddings that also use audio, but they do maintain temporal video context. And so we want to index those once again as these leaf nodes, treat them as the most granular setting possible, and index those every 10 to 15 seconds. This will tell you a lot of things. Any core visual cue, these are extremely granular in these 10 to 15 seconds. If I am using my hand, if I pick up these sunglasses, put them down, the 2 seconds that took, those will more often than not be picked up. And so we can rely on these visual embeddings, these multimodal embeddings a lot to capture these really small chunks, exactly what happens within these little areas. We also want to determine when the action happens on screen, when there is a prominent color on screen, when there is a zoom in or a zoom out, a lot of these multimodal embeddings are trained and built in the context of, okay, you want to look through these longer footage, and I want to find where in this footage someone is doing um, moving from left to right, or where someone is zooming out or zooming in. These are all things that are part of the training, and will more often than not be included. Once again, I'll give some examples later on, kind of like counteracting that part. But um, any core action or any core visual cue will be spotted by this. This is extremely important because this handles with very low latency a lot of the core problems with finding something that happens on screen. And by treating this as the leaf nodes, we can deal with a VLM later on and just deal with pure RAG right now. And I guess a good way to think about multimodal embeddings is there's a bunch of different ways that they can be trained. Some of them with early fusion, some of them with late fusion, some of them just as contrastive learning models, similar to how Clip was trained. But none of these really seem to improve the quality of our embeddings that much. You're able to, I guess, like get these core ideas, but there's still really a lot missing. We can't just embed a bunch of frames. Once again, for example, a lot of these models are trained by just taking in a bunch of back-to-back embedding models, embeddings of images, and then trying to throw some attention at it to learn the relation between one frame and another frame. Which is, yes, that is the ideal way to go about this. But there would be so many gaps that you can only get the core idea of what's happening. And try to go more granular, try to extract data that wasn't necessarily a part of training data, you just end up with this huge problem where you just get really, really, really vague embeddings. So it doesn't really matter what type of fusion you do. It doesn't really matter what type of embedding training you do. This is a core data problem because there is so little labeled text and video pairs out there. That makes it really, really hard for us to know and verify this level of information. So sure, there's a lot of unsupervised techniques where you can go and you can take these 1,000 YouTube videos and just rely on descriptions from the YouTube video as some potential cues, or ask an image VLM to tell me what's happening in this image, what's happening to other image, and then reason about like what might happen in the middle. That is, I guess, the core potential idea. That is the ways in which you make it around these problems. But we still that doesn't mean we can rely on the quality of these embeddings. I guess here's a really good example. So as I was starting my internship, I went and I just made a really simple video of a ball moving from left to right. It was a red ball, and something about these different multimodal embeddings is the more modalities that you introduce, the farther and farther away your text to this modality reference will be. So for example, if you have a ball moving right, and I input this video, and I also input the text description. When I use an image embedding, I'll get a score of about 20. This is taking all the image embeddings and bringing them up. Surprising is when I do ball moving left, I get an identical score. That's just because we have the exact same frames happening, and so their embeddings have no meaning at all. Yes, when you want to do red ball versus blue ball, the red ball will score a lot higher every single time because those features are there. But the core idea of moving left and right is just never there. Then a VLM embedding. So this is taking kind of the beginning part of earlier late fusion, taking this embedding from the transformer and applying it to your input text and your input video. And we get a score of 0.05. And when you do ball moving left, you get a score about 0.045. This difference is so granular that it is very, very, very hard for us to get to show like a core difference between the two. You're dealing with text. If you have if you have I am happy and I am not happy, those embeddings will be very far apart. There will be a noticeable difference, at least because of the semantic meaning. We are not there yet in the context of VLM embeddings because of how far away how far away we are from like a truly universal embedding in that context. In this case, it is so hard to justify that we can do a difference between 0.05 and 0.045, at least at scale, that we want to use visual embeddings for the context of a red ball and less for the context of it moving left or right. That's not really important to us right now. We're getting the cues of a ball moving. We're getting the cues of red. And this encapsulates enough for the majority of our research. But once again, we still want to find the video of the ball moving right. And we get 2 videos, ball moving right and ball moving left, which is why we're going to now use a VLM. And a VLM can do text embeddings of the VM outputs. The VLM would say this is a video of a ball moving right most of the time. And by indexing that text to text embeddings will always be higher than any text to image relation. Even if it's a text describing the exact image versus 2 pieces of text that are relatively similar, the text will always be higher. And so this is a lot better metric when you're dealing within the same modality. If you're dealing with 2 different modalities, you have to do a lot of manipulation and a lot of relative weights to figure things out. If I can determine, if I can index this video and say this is a red ball moving right, I can just do text embedding and get the top result. This is a big consideration when doing RAG and across multiple modalities, because there are trade-offs. If you want to spend more, you want to use a VLM to get you this description. Potentially the description is going to be useful for you in multiple contexts, and not necessarily just for your embedding, but also for other using contexts. Then I think it's useful. But for the most part, VLM embeddings can handle a decent amount. In our context, we knew we wanted to do a VLM because we want to use text indexing to encapsulate what's happening across a large amount of video, which is why, in addition to visual indexing and text indexing, we also chose to do highlight indexing. These are what I call the parent nodes of our whole analogy earlier. This is going to be a bunch of highlights that represent from 10 seconds to a minute of just some core thing that has happened. Across however long the video may be, this will describe every single thing it sees visually in a very, very concise description, as well as it will have continual context of what's happening before. So using a VLM, I can, across the first 10 minutes of the video, you can track every single piece of information you want. For example, the video montage, and then there's the video transitions to a live stage with a large screen. So now, if I want to look up a large screen, there are now 3 ways where I can find large screen. The first way is if someone mentioned large screen, which is more than unlikely. The second way is if you want to visually index that. And the problem is, at least in this context, there are just so many videos with screens that finding a large screen may not always be the top hit. This visual indexing is really important, and it tells us exactly. And so all of these highlights at the end are then aggregated together to create a parent node of those parents, which is going to be our root node. Our root node is going to be your title and your description, and this will encapsulate everything that happens across the video, whether it's 5 seconds or whether it's an hour long. And so there is if you are dealing with a large amount of footage, a very smart thing you can also do is do auto tagging. We are putting this through a language model anyways, a vision language model. And we are also doing structured outputs. So why not just retrieve as much information as possible? Sure, it can tell you what's happening. It can also classify this footage. It can also tell you people's names that may have been mentioned. If there was a celebrity showing up on screen, if there was some core organization, if there was a watermark, these are all things that we can do with VLM indexing that honestly make it a lot more useful as a solution. For example, from now on, if I want to look up an interview where this happens, I no longer have to rely on all these embeddings coming together to index both interview plus what I want. Because we've already done this pre-indexing, I can just identify interviews and then do my indexing and then focus my embeddings more on the content that I want and just reduce our search corpus and our search space. That is the core idea of like highlight indexing. It's because you have a wide variety of different types of information you can share. You can store this information in multiple ways. We chose to store both multimodal embeddings and text embeddings for things that are text first. One thing that we realized, I guess, going back to this example, when you want to deal with multimodal information, you are inherently fusing one modality into another. You are teaching your text embeddings that for this text, here is an equivalent video. So therefore, from now on, you embed them, try as close as try whatever possible to embed these to be the same thing. It is extremely difficult and very rare that you achieve parity here. That your text embedding for some video is embedded in the same way that this video is. There's always some differentiation, which is why we get these like really weird scores here. Which is why the more modalities you go into, the farther and farther and farther away your text will be. Even if relatively to another embedding they'll be closer, it's still really hard to make the differentiation. There's a lot of like hand tuning, which is why we kind of focus more on if you are to do a text related search and I've been looking for text information, do a text embedding. Those text embeddings are a lot less noisy. When you do a multimodal embedding training, you may lose some of the quality you have in your text embeddings. So just use text. Text is what's known. It works. If you want to do a visual embedding, a visual search where there's no text preprocessing, of course, use your multimodal embedding or whatever that may be. But whenever you can, try using text because it is more battle tested and it works. And it is very rare that those existing texts embedding that quality is going to degrade as you go along. And so now we have our visual, our transcript, and our highlights. We can now do hybrid retrieval. We can search across the different highlight text and visual components for basically whatever the user may want. And this is really important because we are now no longer missing these core things. If you want to find a piece of, like, I guess, like the most related thing or query, the most related response to your query, you now have 3 different indexes in which you can search for, and you can like aggregate those in different ways. Those are highly dependent on the quality of your embedding model, plus whatever hyperparameters you want to use, whether you want to weight highlights more, whether you want to weight transcripts more. But this now gives you a bunch of different axes to do search across. And by treating it like a tree, we now have multiple different levels of depth that you can search across. And I'm looking up for a highlight of Brian searching Ethernet cable. A lot. For example, the first thing that shows up, this might just be the entire video that is relevant. Or this is, for example, a 45-second clip of a 10-minute video where he's finding the Ethernet cable, and the rest of it is just blank screen. It doesn't really matter. If you were to use purely visual embeddings or purely transfer embeddings, you would never get this level of granularity. And so this kind of brings us back to like how we're now treating a video like our initial tree example. You have a video, there are highlights. Those highlights are each broken down into multiple different types of modalities, each as granular as possible. And these all go down, down, and down, and down. And so this is really, really useful because we want to not just search for footage. We want to give a language model understanding of your footage, which is why at Keynote, one of the last things that were done was creating chat. Chat is how you're able to search through a large amount of footage and ask any question and use these tools really intelligently. Part of this was teaching the language model to use these tools. Yeah, obviously these tools may not be the most intuitive. There's a lot of data that's being returned. And so there's 2 parts of generation. One is how do you give the best response to a language model to understand footage? And 2, how can we make sure the language model is able to access like as much footage as possible? How granular it can get? How much control do we give the language? So I guess the example I'm showing you on screen, a couple others will be very, very, very relevant here. So for example, here, when Socratica, there was in this event, there were so many clips of people just mentioning why Socratica was important to them. There were interviews that were done. There were live interviews. There were people on stage saying it. Everyone has their own different purpose. Everyone has their own different meaning behind what they're saying in the context. But we want to get everything. We want to get every single time this is happening. So across this 50 hours of footage, we are showing a combination of verbal and highlight hits. Here, these are all a bunch of highlights. These are people describing what Socratica means to them. And alongside, we can also throw a large amount of transcript context and other indexing context around it. So the language model can do its own independent reasoning. We found that GPT-411 was a great model to use here because of its large context window. And because now that we're back in the text domain, we can rely on this context window scaling. We can say, yeah, sure. As the context window increases by a significant amount, we can just throw this on a very competent language model. We could not do the same when we just had videos. In the same way, if there are visual cues of when people say something, or for example, down here, Ishan says Socratica means love of making. That is a visual cue that was hid through a semantic text embedding. That is completely different than the way that Faisal said that interview defines Socratica as intersection between creativity and hard work. Those are completely two different things, but they both add meaning to our initial prompt. Another core thing is, let's say you have a large amount of footage, but not necessarily all of the footage is the thing. For example, here is a large corpus of text of videos that we had. Two of these videos had verbal mention of MIT. One of them had a visual reference. We wanted to find all videos related to MIT. And so you can figure out, okay, if you do a search for MIT, we'll get two verbal results where people mentioned MIT or the Massachusetts Institute of Technology. And there's a highlight that looks at the visual cues, sees MIT on screen, puts it in the highlight. Now we do a text semantic search on those highlights. We can now find the one with MIT's campus, as well as surrounding context. Why is MIT's campus mentioned here? What's important about it? Well, it's important because they showed military technology demonstrations and more. And if you want to go as granular as possible, you just mention, okay, where exactly is MIT mentioned? And so in the first one, we're able to see the very first shot where the crowd gathers around MIT's campus. Here, we can go as granular as whenever the word MIT was mentioned, between 46 and 51 seconds, as granular as you can. Here, between 11 minutes and 54 seconds and 12 minutes and 25 seconds, this is a highlight where people are mentioning things about MIT. We want this entire thing. This is all incredibly, incredibly useful information for a chat to have. For example, if you want to create a compilation of all mentions of MIT, or you want to contribute to a larger documentary at MIT, and you have all this archival footage, for example, you don't have that. You have every single time MIT was mentioned in multiple different contexts. And then also, here's the entire movie Dune. We just threw the entire movie in there alongside a bunch of other movies. And we want to see, okay, does the chat know the plot? Does the chat really know what's happening throughout this, 2.5 hour long movie? And yes, it does. We're able to use this kind of tree context to understand these different events. And then across these different events all contribute to some larger plot, and it becomes larger and larger in terms of depth. And so we can ask, does it become the Messiah? And we can answer these questions. We can answer a lot of granularity as to when things happen, and a lot of granularity as to when specific things happen. When does the turning happen? That's not necessarily just going to be a visual mention. That's not just going to be a text mention. It is some overall event, some plot point. And so by using this VLM indexing, we're able to extract this information. And so this is like kind of going into like more detail, like into the Dune example. We have very, very, very in-depth descriptions between half an hour, 30 seconds to like a minute long, explaining what's really happening between these indexes. Not all these indexes have to cover every single second. If there is parts that are not necessarily important, we don't want to classify those as moments. Those are just visual cues that can be indexed if necessary. You don't always have to cover every piece of text as well. And so I guess this is probably one of my favorite examples with Keynote. I uploaded a lot of just personal footage on my laptop I think this is from my hackathon that I did 2 years ago, where I first built Portal, the wearable you put on your hat. And instantly you can find anything that visually has stickers on it. You want to find everything that is related to a laptop. In-depth descriptions of what happens, what's on these. For example, personal showcases laptop stickers, identifying origins from E4 to Loop, hackathon season 2023, and a lot more. These are very, very, very in-depth indexes that you would not be able to get with just visual embeddings. The fact this comes from each order would be a very contextual thing for a transcription model to find out, and would just never be identified by some multimodal embedding. We also were able to do some pretty cool experiments with MCP and using that to directly interact with your video editor. So you're able to give it a bunch of footage from a hike, asked it to make a compilation of all funny moments with animals, and it can do it directly in your video editor. And so this is like kind of the flexibility that using Keynote gives you. You can find the exact moments from some millisecond to some millisecond of when videos of animals are there, put them together in a contextually funny way using a language model, and then produce these relatively high quality edits, things that happen in your life and with your footage. We kind of break it down into this kind of ingestion pipeline. It is just go a bit more into depth into that, but this is kind of like the core idea. You store revisions. You store what was said, you store what was seen, you store what was highlighted. You then have a router which is able to do sparse indexing on text as well as dense re-ranking on this text trace responses. Plus, you're able to do visual indexing on the visual cues. We do multimodal embeddings for visual cues and text embeddings for verbal highlight semantics because of this really because of the difference in quality that you get with text embeddings versus multimodal embeddings. And then we rely on these language models to take in this large context of different highlights and the surrounding text that happens and the surrounding visual cues and give you this answer, tell you what's happening. And so a big part of making Keynote feel magical, as people call it, there's two parts. One is ingestion. That is something that somewhere in the call, there's Alec, who spent a long time working on that. He being able to ingest footage was really important just to make it feel like you're automatically indexing as fast as possible. Some decisions that were made were really important, which was whether to asynchronously or to sequentially, whether to process things in parallel or sequentially. And think about it like this. Ideally, we process everything sequentially. You find out who was in the footage. You get the transcripts. You take all of that information you get from visual cues, from related footage, and you put it onto the highlight indexing. And the VLM is able to index now with a lot more context. You can also throw a lot more graph context as well. This is kind of hard to do. This is not really ideal because it just takes 3 times the length. And so we realized that visual indexing and the idea of creating this aggregate was a lot more useful. We also like to account for the case of okay, whether you're doing precision versus recall, if you are intending, if you have a very, very recall-based thing, that's if the user knows their footage a lot. That's if they know phrases that were said, know what was seen, knows what a person did, what's happening. So if they want to search something up, they already know what was said. They just don't know where to find it. If it's a black box, you have to deal with more semantic kind of problems. Know when, how this person, identified person, relates to the whole plot. Using semantic embeddings instead of the sparse text results for text, because I don't really know exactly what it's saying, but I want to know when someone mentions the word compute, for example. And so for Keynote is really useful that we focus more on recall because filmmakers know their footage. They wrote the plot. They know what's happening. Editors know from every moment in time what someone's going to say. They just don't know where in the footage that exact moment is. There are multiple cuts. Not everything is just, I know exactly where in the footage it is. If you're dealing with a black box, focus on semantics, separate visual and text, and focus a lot more on that pre-indexing to make those search corpuses a lot smaller, which makes your final results a lot better, a lot easier to deal with. You can also do a lot of graph indexing. If I have sunglasses and someone else has sunglasses, and we can, to some degree, index this, that's super easy to do. You can now relate these two pieces of footage in some degree. Auto tagging is very important. Being able to use graph databases is extremely important because you can now relate this vector DB with this vector DB, these two roles. If you want to do, if you want to have language models reason, you can teach those language models to continually use these tools in different ways and get as many visual results as possible. And then I guess one thing that I experimented with before that like we didn't necessarily find useful, but you might find useful is prompt decomposition. For example, when I would ask the question, when did I talk to Ian about laptop stickers? Instead of just throwing this entire thing into an embedding model to get the top results, and then later on into a language model, we're able to extract the different core parts of this prompt. When did I talk to Ian? So Ian is the person looking for, so I can do a filter on Ian. And I can also do a specific search for laptop stickers. So now we're focusing on very clear and very signal focused, very little noise for these searches. Yeah, and so this is kind of like the core methods that we use at Keynote to kind of search through like really, really, really intense footage. I think if time permits, I think a demo could be nice. If Jason, you want to pitch in whether a demo or whether answering questions or what the best things.
We only have 10 minutes left.
Cool.
So.
Okay. Yeah. Let me take a look at some of the questions as well.
Did I hear yes or no on demos?
Let's do a short demo.
Let's make it quick. Yeah.
All right. Great.
Great.
Just want to confirm that everyone can hear me.
Yep. Sounds good. Yep. Sounds good.
Awesome.
There's an echo.
Yes. Just fix the echo, I believe. Great. Well, I think we've got a few fun examples that should hit pretty close to home, actually. Let me just share one of my screens here and confirm that everyone can see. So here we are. I have some fun footage here, and what I have inside of here is, I think, a fun example of how a lot of these core concepts that Rajan is talking about can come together in a very real example with real footage. For example, if I filter by a particular guy who shows up a lot in my footage, and then I click on a given example, you can see a lot of what Keynote is doing in action, right? There's a man with dark, messy hair. He appears, turns out that I can actually see at a quick glance not only every single thing that he's talking about, but then I can kind of summon that within my larger file system and such. Rather than going over, though, a lot of the ways in which Keynote integrates with the workflow of our core users and our core customers, what might be fun, though, is just to talk about the exact ways in which all of the very fun stuff that Rajan is talking about comes up, whether it's filtering by a particular person, but more excitingly, classic embedding search. Weird formatting, weird spacing, all of that fun stuff can happen, right? Anything from particular moments that score really well, because there you go, there is indeed a person on a laptop, and so it'll show up. I think what's notable here, though, is that you can kind of see visual embeddings doing okay. There is stuff where there's people on a laptop, but is that the best way to do it? Not exactly, right? It's by taking advantage of transcripts and taking advantage of highlights and taking advantage of what vision language models came up with in order to really get what a lot of people are caring about. Kind of intense stuff that there was no expectation that modern vision embedders were able to capture, right? By giving the user full access to the different indices that I think a lot of other software would kind of abstract away from you, you can do a lot of really fun stuff. And you can kind of compose things together. If I want to find all of the best moments with a particular person, we can really put ourselves in a situation where we can have a lot of these different concepts that Rajan was talking about come together. While we wait on our beautiful cache to pile up in this kind of instance of Keynote that we have here, we can see how, through these different concepts, we can have Keynote automatically bring things together. Jason talking about dismantling online criminal rings. I wonder what that's going on, right? And then there you go, and it will show up. I can have an entire map of all of my footage as if, I wasn't even there to shoot it. For footage that I was here to shoot, I still very much rely upon Keynote for, I would say, understanding what happened over the course of, pretty vast amounts of things. that's a little bit of what I have to share here, a little bit of the different ways in which Retrieval has come to make Keynote feel significantly better. Obviously, there's much more to Keynote than what I just showed you here, but that's a tiny portion. Would love to dive into questions for Rajan's awesome talk as well.
Yeah, I think just looking at some of the questions people are asking, people are really curious about what kind of decisions you make when you are choosing models. There's probably going to be ELM selections, text embedding models. I see that there's like, GPT-4.1 here. How did you make those decisions when it came to choosing what kind of models to use?
I really, yeah, I want to defer all to Rajan, but I just want to say I love it in moving example. I think that's a perfect example of starting very, very small, right?
Yeah. So I won't really go too much into like some of the choices we made in terms of like the final decisions, but in terms of like our thought process into reaching those, we noticed a lot with like vision language models, with visual embedding models. A lot of them were that whole case of image embedding concatenation or averaging. You want to maintain these temporal features. And so a lot of these are honestly pretty comparable. You'll find very, very similar results across like different no matter how big or small. They'll all do relatively well, but you want to make sure that there is this temporal feature. You want to make sure that it is able to take 10 to 20 seconds of length video. And we also, there are some that offer up to 30-minute of embeddings. I think that is inherently unnecessary. There is too much context you're losing in those examples. And so those stats where they boast the capacity of the context length in those cases, I don't think that's as useful as the ability to interpret like an action that's happening in a video. There are so many ways to go around indexing footage at a smaller scale that is a lot more valuable than it would be just to have this like large like amount of video in a singular embedding. And actually it's likely against your favor to throw what's the equivalent of an essay into an embedding than it would to be a sentence, if that's a comparable example. Luke may have some more context to like, I guess, other model decisions, but in terms of using like a VLM, use a VLM that is well known. Don't necessarily use a VLM just because it's a little cheaper. Do not spare on that front in terms of cost. If you order a spare on cost, spare a little on your embeddings, and then throw more results at a re-ranker in that case. But when you're dealing with video, it's hard to spare costs and also get quality results. It's way too new of an indexing field.
Yeah, I heard that you called out some re-rankers. I think another question I thought was pretty interesting was just how do you think about blending the re-ranker across things like verbal, visual cues, and transcripts?
We treat language models with large context as a very good re-ranker for our case, especially if it's a smaller language model. I think, for example, GPT 4.1 Mini and Nana are great examples where they are really cheap, but they do have that million context window. What I think of it is like if you have a video at 10 minutes to 11 minutes, there is a lot of things that were said. There are a bunch of visual results, like in that case, and there's also those highlights and those indexing that happens. You want to throw all of that plus the preceding and post context into a language model and let it kind of determine what's happening. The highlights will give you context of what's happening in a video. The transcript will tell you what's happening in terms of what's being said, but there's still obviously no like reasoning that's happening around this footage. And so I'm not sure about the current state of re-ranking in terms of search, but in the context of a language model, we treat language models like re-rankers because we're now bringing everything into text. Now it's all just in the text domain.
That makes a lot of sense. I know we're basically at time. I also want to make sure we're respectful for everyone else's time. But as for the slides, will you be able to share some of the slides with us?
Absolutely. Yep.
Great. Yeah.
I'll send them to you and you can distribute them however.
Perfect. So I think in the next like day or two, we'll be able to put the video out, send an email with all the other resources, and we'll be able to share the YouTube video link as well. Rajan, Lucas, thank you so much. Yeah, we'll share all the links at the end with emails. Awesome.
Yes.
Thank you so much.
And I loved seeing everything come together like this. So thank you.
All right. Take care, everyone.
Thanks, everyone.